All right, so moving on to the last set of problems. So question 40 says, find the equation of the line containing the median of the trapezoid FGHJ. So remember, the median is going to bisect the sides. So we can see that these are the two parallel bases. So that means that here are my two sides, okay? And so we have to, the midpoint, we have to find the midpoint of those two sides. So let's start with F and J. So remember, the midpoint is just half the distance of the X, or you're changing X, half the distance and you're changing Y. So half the distance of X, so X, I travel 2 units, half of that would be 1. Okay, so I know I'm looking somewhere on this line. And then half the distance if we're changing Y. So if we're changing Y, I went 1, 2, 3, 4, 5, 6 units. Half of that would be 3. So I'm looking at this line, bring them together, and that gives me my midpoint. And so the midpoint here is located at 1, 2, 3, 4, at negative 5, comma, negative 3. And so I also have to find the midpoint from G to H. So once again, the midpoint is just half the distance and you're changing X, half the distance changing Y. So changing Y, we went 2 units, so half of that would be 1 unit. So we're looking somewhere on this axis. And half the distance in your X, or half the distance in your changing Y. So we go 1, 2, 3, 4, 5, 6 units. Half of that is 3. So that means we're looking on this line, bring them together, and we get the midpoint of GH, which is located at 2, 4. And so really the only thing that's left to do is figure out what that line is, or the equation of that line. Yep, find out the equation of the line. So one of two ways we can do this by finding the slope. So finding slope is changing Y over changing X. So from negative 3 to positive 4. So from negative 3 to 0, that's 3 units. From 0 to 4, that's 4 units. So altogether, we changed, or we went up 7 units. For your change in X, how many units do we get from negative 5 to positive 2? Well, from negative 5 to 0, that's 5 units. And from 0 to 2, that's 2 units. So we went a total of 7 units, which gives me a slope of 1. And if you can see on my graph, here or there, I have my y-intercept, which is positive 2, or b equals 2. And so now I can write my equation in the form of y equals mx plus b, where m we just found to be 1. So we're just going to, we can put it as 1x or just x. And my y-intercept was positive 2, so y plus 2 is my equation for the median of that trapezoid. 41, it says find the value of x. So if you notice, here we have 2 vertical angles. Vertical angles are always congruent, so my equation would be 7x plus 1 equals 12x minus 24. And to solve for x, we're first going to subtract 7x from both sides and add 24 on both sides. On the right side, the 24's cancel. On the left side, the 7x's cancel. On the left side, 24 plus 1 is 25. On the right side, 12x minus 7x gives me 5x. Divide both sides by 5, and we get x to be 5. 42, there's 2 ways to do it. Probably the easiest way would be, if you notice here, once again we have supplementary angles. Supplementary angles means they add up to 180. So 180 minus 100 gives me an angle measurement of 80. And so the second thing is, we have 3 angles inside a triangle. And here's my triangle. Now remember, for a triangle, the sum of all three angles is always going to add up to 180. So we're going to add these two angles and subtract it from 180. So 80 plus 45 gives me 125. And so then we do 180 minus 125 gives me a measurement of 55 degrees. And so here, the value of x is equal to 55 degrees. Last problem, and it takes us back to proofs. So here we have a scaffold proof, so they're giving me about half of my answer. I gotta fill in the blanks. So the first thing is we draw a segment, or in this case, we draw a diagonal QS. And the next step would be to mark the diagram, but they already marked the diagram for us. They're telling you PQ is congruent to RS and QR is congruent to PS. The next thing they're telling you is that segment QS is congruent to segment QS. So what that's telling me, or what that does for me, is it creates two separate triangles that both share side QS. Now that's important because if you notice, the two triangles are already sharing, or they also have two other sides that are congruent and corresponding, which allows me to prove that these two, or show that these two triangles are congruent. And now we will have to write the two triangles that are congruent. So the first triangle, the order doesn't really matter. What the order matters is on the second triangle, because it has to follow the same order. So here we went triangle QRS. Now if you notice, from Q to R, we went along the side that had two marks and then went to the side that had one arc. So in order for the triangles to be congruent, we must follow the same order. So for the second triangle, my two sides are there, so I have to go from S to P and then P to Q. So I label it triangle SPQ. And the reason that they're congruent is by side of congruence. And the next step would show that these two angles, or really these four angles, two set of angles are congruent by corresponding parts. Congruent triangles are congruent, or CPCTC. So now let's actually go back and mark the diagram with what the information that they gave us. So they're telling us that angle PSQ, so this angle here is going to be congruent to angle RQS. And the other angle that they're giving us is RSQ is congruent to PQS. And that's important because if these two angles, or these two set of angles, are congruent, that's telling you that we have set of parallel lines. And so the only thing we got to do, or the only thing we got to show, is that is to tell which are the two set of parallel lines. So my two parallel lines, or my two set of pair of parallel lines, is QR is parallel to PS, and QP parallel to RS. And the reason would be is that they are alternate interior angles. Now here, because we started with angles and talked about the lines, then we add the word converse at the end.